We haven't done anything new so far in this chapter. This is all review from algebra. Okay, I will pick 67. In 67, we have natural log of x plus 3 plus natural log of x minus 3 equals natural log 7. Okay. Log is a function with problems. Let's state restrictions first. What is the restriction for this? What do I have to write? For this to exist, what has to happen?
X plus 3 is greater than 0.
Excellent. For this, what has to happen?
X minus 3 is greater than 0.
Perfect. So this means greater than -3. This means greater than 3. If you have any doubts, you can always graph greater than -3 and greater than 3. What is the domain? There is nothing here. This is a number. It's 7, greater than 0. There is no restriction for that piece. That's, I would have mentioned it, but there is nothing to write for that one.
It's 3 to infinity.
Of course, both colors. Good. So, if this equation has a solution, it must be here. If I solve this and I get x equals -4, I'll say no solutions. I can't use -4 in any of these logs. So this is absolutely crucial to find from the beginning. Or you can say, no, I don't want to state restrictions, but I promise that whatever I get, I'm going to go back and check. That is also a legitimate method. But since this is so easy, I prefer to find the domain. But you can say, no, it's not easy for me. I will solve the equation, but I promise forever and ever, whatever I get, I go back and check. For me, that's more difficult because I may forget and move on to something else, a different problem. But if I state the restrictions on such a problematic function from the beginning, chances are that I will not forget to say, hey, wait. -4 is not here, so it cannot be a solution. But you're allowed to choose one method or the other, but you must choose one. So I chose the restrictions or the domain. I know that the solution, if it exists, has to be here. If it's not here, I'll say, sorry, the equation has no solutions. Good. Now I have to use properties of log. Am I still centered? I think I am. I'm going to copy the problem here. X plus 3 plus natural log x minus 3 equals natural log 7. How do we condense this? And you can say, condense? What are you talking about? So these properties are dynamic, meaning this can be condensed like this. This can be condensed like this. This can be expanded like this. Condensed, condensed, expanded. From expanded back to condensed. From expanded back to condensed. From condensed back to expanded. So now I have to choose one of these three that fits this and condense it. So how do I condense?
I was going to say, we do log of parentheses a times b.
Yes, x plus 3 times x minus 3 equals natural log 7. Indeed. So we had to use this property because of this symbol. So log of a plus log of b is log of ab. So now, I have natural log of a quantity. And on this side, I have natural log of 7. In which situation these two will be identical? I have natural log of something equals natural log 7. How much this quantity should be, so then the left-hand side equals indeed the right-hand side?
Would it be 7?
Exactly, mandatory. There is nothing else. This must be 7. Natural log 7 equals natural log 7. There is no other number. So then x plus 3 times x minus 3 must equal 7. Excellent. Now, can anyone give us this product? We discussed these rules, these special products, on the very first day of classes. Can anyone give us this answer quickly?
X squared minus 9.
Excellent. I have to move 9 to the other side. What do I do now, and how many solutions I have to find?
X equals positive infinity. I mean positive 4 or negative 4.
Excellent. I had no idea. I just made this up. I had no idea that it was going to be like that. Just lucky guess. So, no, only Hubert is with me. Anyone else?
I'm here.
Good. Anyone else would like to say anything here?
X equals only 4.
Exactly. Because negative 4 doesn't fit here. So this is the only solution. If you don't state the domain, then you have to go back and check, which sometimes I find more cumbersome. Good. Any questions on this problem? Any questions? Okay, I would like us to finally get to some more problems. A cup of hot coffee is placed on a counter and allowed to cool. Fine. The temperature uppercase T, I don't like this uppercase T and lowercase t because it can get confusing, but that's fine. In the same problem, they can use X and T, doesn't matter. The temperature T in degrees is in Celsius. So T is in degrees Celsius and T is in minutes. Okay, perfect. So T of T is 30 plus 45 e to negative 0.023 t. That's the function. Okay, so we put the hot coffee and let it cool down. Fine. What was the original temperature of the hot coffee? That's our first question. What is the original temperature? What do we mean by original? What does original mean? Every time we talk about initial or original, what do we mean?
I was going to say when T equals 0.
Exactly. When T equals 0 minutes. So we want to find T of 0. Again, we start from where we should, here. How much is 0 times negative 0.023?
0.
Perfect. How much is e to 0? Careful, we discussed e to 0.
1.
1. How much is 1 times 45?
45.
How much is 45 plus 30?
75.
That's it. Good. Going back. Part B. What is the coffee's temperature after 20 minutes? What am I asked to find now? What am I asked to find?
What's in temperature after 20 minutes?
Good. So this is 30 plus 45 e to negative 0.023 times 30. I cannot do this by hand or in a blink as we did it. Okay? I have to go to the calculator, and I have 30, and then plus 45, and then e raised to power. You know I love parentheses. Negative 0.023 times 30. Oh, I wrote 30, but it's actually 20 minutes. Sorry. Good. Okay. And enter. 58.41. 58.41 degrees Celsius. And I have to correct that. So this is 20. It says 20 minutes. T of 20. So it drops from 75 degrees Celsius to 58.41. Part C. When will the coffee's temperature be 35? What am I asked to do now, and how do I do it? How do I proceed?
What I would do is put 35 on the left-hand side.
Yes.
Which equals 30 plus 45 e to
Yes.
0.023 times x.
Very good. Brilliant. Excellent. What do I do now? And don't ever forget, clean it up, clean it up, clean it up. Make it as easy as possible. So let's clean it up. How do I clean it up? First step. First step, first step, first step.
Divide by 75.
Careful, very much. Careful, 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 careful.
Oh, my bad. Divide by 45. Divide by 45 minus 30.
Subtract 30.
Very good. First, we have to subtract 30.
You can't do both at the same time?
Nope.
Fine.
We have to clean it up by subtracting 30 first. And now we clean it up doing what?
Divide 45.
Yes. Now we have to divide both sides by 45. And you can keep it as 1/9 or 5/45. It doesn't matter. Now it's completely cleaned up. And when I got to the stage in which it's completely cleaned up, what do I do now?
Natural log.
Yes, now I apply natural log to both sides. This stays as is. I don't care. It's just a simple number. This is negative 0.023t. I should write again times natural log e. Why don't I?
It disappears.
Because
it
equals 1. So then I have t equals this over this. Careful how you write it. This is a number at the top. Natural log of 5/45 over negative 0.023. And I get that t is approximately in minutes. So I'm sharing my screen. So we have natural log Let me clean up all this here. So we have natural log, and in parentheses 5 over 45. Oops, I didn't mean that. I meant 5 over 45. Close. Divide. Don't forget parentheses for the denominator, please. We start with a negative symbol, not the negative operational negative, but the negative symbol. 0.023, close and enter. And the answer has to be positive, and it has to be minutes. Okay? When it drops from 75 to 35. So 95.5 minutes, 5-3. It seems quite big. Let's look at it just, let me just look one more time here.
I got 9.553.
So I put too many zeros because it seems too big. I don't know what it is. When will the coffee's temperature be 35? So we have 35 equals 30. So that was 5. And then 5 over 45. And then negative 0.023 t. And then we applied. Let me see what I did here. So natural log of 5 over 45, that's correct. Divided by negative 0.023, that's correct. Yep, that's what I'm getting. Did you get something else?
No, I got the same answer to you. I guess I forgot to put a 0 in.
Yeah, it seems quite extensive, doesn't it?
Yes.
Okay. There is a last question. Let's take a look. There is part D. Find the limit of this function when t increases without bound. Well, that's not possible. But so they want us in part D, limit as time goes by, where does the temperature go? And explain what this number represents. So I'm going to write the limit. I'm going to replace t of t in here. So I have limit as t approaches infinity from 30 plus 45 e to negative 0.023 t. And we want to talk about this. Okay. What do we do when we're asked to find the limit? What is the first thing we need to do when we are asked to find the limit? In all cases, we're asked to find the limit. What did we do? Always. First step. Anyone can remind us the first step? Anyone?
Plug it in.
Plug it in. I have no idea what this is. But where do I plug it in? T approaches infinity. So let's start step by step. When t approaches infinity, where does negative 0.023 t go? What does it approach? When t approaches infinity, and I multiply it by a negative number. So infinity times a negative number, even if it's a small number, it's this infinity goes on forever. So infinity times a negative number, where will it go? To negative infinity. Would you agree? Anyone?
Why wouldn't it go to 0 instead of negative infinity?
So if this is 10 million, and you multiply it by negative 0.023, it will be negative 10,000.
Yeah. which is approaching 0, right?
Negative 10,000? You wish.
Now,
So if you owe me $10,000, do you think that I will say, oh, actually you owe me 0?
no, you're right.
Absolutely never. If you owe me 10,000, you have to give me 10,000. I will not take 0 for it, right? So it's a joke, but you know what I mean. So as t approaches infinity and I multiply t by a negative number, it will approach negative infinity, guaranteed. Good. What do we know about e to negative infinity? Well, I shouldn't write this, but it's important for you to see it. We discussed this limit a long time ago. Small over huge. What is small over huge approaching when, in this situation, when t approaches infinity? 1 over huge.
Now would it be 0?
Yes, this will definitely approach 0. So if this approaches 0, this approaches 0, and then what is the limit then? And that's it.
0?
So what is the limit?
No, 30.
That's it.
30.
30. Because that's the ambient temperature. It cannot be lower than what the ambient temperature is. So if it's 30, that's what it is. That's it. I will not